So hello. So thanks to the workshop to give us the opportunity. The title of my presentation is Geology and the Polymetallic Nodule Resource on the Sediments area, Northwest Pacific Ocean. My presentation has two sections. The first one is the regional geological setting, and the second one is the Polymetallic Nodule Resource on the Northwest Pacific Ocean. The state area in my presentations is located at the edge of the Mariana Trench, west of the Central Pacific Seamount Group, north of the Carolina Seamount Group, and south of Shatsky Ride. The main geological units in the state area include the Seamount Group, such as Microscopic, Magellan, north of Marshall, and the abyssal basin, such as Pickford and East Mariana. So, three Seamount Group and the two abyssal basin are the main geological framework of the Northwest Pacific Ocean. We found that the area of the international seabed is about 2.1 million kilometers squares and include about 165 seamounts in this area. The seamounts occupied the area about 319,000 kilometers squares. Number of the seamounts with a summit depth more than 2,000 meters are nearly half of the seamounts, but these seamounts only occupied about 20% of the whole seamount area. The seamounts with a summit depth from 1,000 to 2,000 meters have about 63, but occupied nearly half of the whole seamount area. Let's see magmatic and tectonic field. The Pacific plate formed in the middle of the Pan-Pacific Ocean before 190 million years. The oldest oceanic crust on Earth can be found in this area. The geomorphology of the seafloor mainly results from large mantle hotspot activity during the late Jurassic through the late Cretaceous. However, the seamounts in the state area are continuous and haphazard distribution. There are four large fracture zones in the state area. They are Northwest Trending, Kasama, Oksawara fracture zone, and the Northeast Trending, Shatsky and Wakahara fracture zone. We can say the tectonic of the North Ocean is wholly different from that of the mid-ocean ridge and the CTZ of the East Pacific Ocean. We use the data of the Geographical to learn the topographical feature between the Microscopic and the Magellan Seamount Group. The depth of the Magellan Seamount Group is greater than that of Microscopic Seamount Group. The slope frequency distribution in the two areas are similar. Most of the area, about 75% in both regions, is just very flat. Seamounts evolution in the state areas has long geological history. The morphology of seamounts results from complex geological processes. Firstly, we can see the summit. Nearly half of the seamounts in the state area are with a depth about 1,000 to 2,000 meters. The summits mostly exhibit conical vertex, flat, or taper shape. The morphology of the summits will result by volcanic activity at the beginning, wave erosion after island forming, and sedimentation after subsidence. Faunas such as echinoderm, sponge, shrimp, fish are mostly found on the summit. Depth of upper flank of seamounts are about 2,000 to 3,000 meters. Most of the cliffs occur on the upper flanks and slope, with up to about 13 degrees. The morphology are mainly influenced by the slope failure from the dike intrusion and the gravitational process. At present, nearly all of the regions with abundant sponge cover were found on the upper flanks. On the lower flanks, sediments are common and the depths range from 4,000 to 6,000 meters. The lower flanks exhibit much flat and the slope is less than 10 degrees. Morphological structures are common in this region, such as slump debris flow channel, and isolated barometric height. The abundance of the fauna is obviously lower than the summit and upper flanks. So a basin exhibits a heterogeneous distribution of sediment thickness. Main surface sediments in the northwest Pacific Oceans are pelagic clay, calcareous woods, and silicious wood. But the pelagic clay is distributed in most areas of the abyssal basin. So made a short summary. Geographic framework would be defined by the three seamount group and the two basins in the northwest Pacific Ocean, with exhibit different tectonic features from the CCZ and mid-ocean ridge. A typical seamounts include summits, upper and lower flanks, with exhibit different morphology, tectonic, and community. So the second section. As we all know, the nodules are ubiquitous on the sediment-covered abyssal seafloor. Nodules have attracted much attention over the past 60 years owing to the huge mineral resource potential. The North Pacific Belt includes CCZ of the East Pacific Ocean, Central Pacific Ocean, and the Northwest Pacific Ocean. It's also the area with high degree of polymetallic resource investigation. There are totally 18 contracts for the nodules in the area, which span about 1.3 million kilometers square. 16 contract area lies in the CCZ of the East Pacific Ocean and one in the Central Indian Ocean basin. Beijing Pioneer High-Tech Corporation signed the contracts for the nodules with ISA at 2019. BBC will fulfill the contract at 2021. So BBC contract area has an area about 74,000 kilometers. The area consists of 4 blocks. 2 of them are located at the Marcus Baker Seamount Group, and the other 2 are located at the Magellan Seamount Group. We use the 154 box core station results to learn the nodule type. 3 categories were determined based on the diameter or long cracks of nodules, large, medium, and small. The results indicate that most of the nodules belong to the large and medium types in the study area. Nodules with many types of morphology were recovered in the study area, but the Scabed nodule and episodic nodules are dominant in the study area. So we think that the nodule types in the Northwest Pacific Ocean are much simpler than those of the CCZ and the Central Pacific Ocean. The compared data for abundance of nodules from box core station in the study area indicates a mean nodules abundance of about 22.3, which is higher than that of the Central Pacific Ocean nodule and the CCZ nodule. Nodule abundance and coverage show a linear correlation in the study area. So as we all know, the relation between the nodule abundance and the coverage from the box core stations are mostly controlled by the nodule types. So I think that that in the study area, the nodule types are much simpler in the study area. The turn-right discrimination diagram indicates that the nodules are predominantly hydrogenetic in the study area. The manganese-iron ratios of nodule also reflects that they are hydrogenetic origin. Most nodules contain a nucleus of consolidated sediments and a small number of them with a volcanic classic or old nodule fragment nucleus. 3 or 4 layers were commonly observed as the internal structures of the nodule. The mineralogy of the nodules include manganese, iron, and gum minerals. The manganese phase has a good degree of crystallinity, corresponding mainly to a delta manganese dioxide. The results indicate that the content of most elements of nodules in the study area are similar to those from the Cook Island EEZ. So compared to the diagenetic and mixed nodules, the nodules has a high content like cobalt and the lower contents like copper and nickel. The lower flanks of the seamounts are permitting area for the nodule resource development in the northwest Pacific Ocean. So our data indicated that the lower flanks of Suda fields have a high coverage of nodules, with many patch distribution. The nodules are distributed with a high continuity in the high coverage area. This is a key difference compared to the CCD, where the distribution of the nodules are related to topographical morphology, and therefore show nodules deposits occur mainly in the band. The large tonnage and the wide distribution of the nodules on the lower seamount flanks depend on the interactions of several processes that include bottom current, seafloor morphology, and sedimentation. So we can see the feeder of the nodules results in the northwest Pacific Ocean. Tips, mantle content, and the forming process of the nodules on the northwest Pacific Ocean are simple. Main mantle elements content of the nodules maintain stable compared to the difference of abundance. Regions with high abundance and continuity of the nodules are prone to be found on the lower flanks. So that's all. Thanks for your attention.